Hi, we are Team 3 and we are presenting our research proposal forecasting water main breaks under climate variation, a data-driven approach. Water mains are critical components of urban infrastructure that ensure the delivery of safe and clean water. A functioning water main ensures the clean water is available to the public, which helps to prevent the spread of water-related diseases. In Canada, the value of water mains assets is significant with an estimated value of 207 billion. The high value of water mains underscores the significance of maintaining and upgrading water main. However, 25% of Canada's water infrastructure is in fair, poor, or very poor conditions. In the US, the American Society of Civil Engineering reported that water main breaks occur every 2 minutes. While there has been a lot of research on predicting water main breaks, few studies have explored the impact of weather variation on the likelihood of such incidents. By investigating the relationship between weather pattern and water main breaks using a data-driven approach, we can effectively and accurately forecast water main failures. This will improve our ability to protect and prevent these events, ultimately leading to more efficient and cost-effective maintenance.
This project, first, the effect of climate on water main failure will be investigated. Then a machine learning model will be developed to predict water main failures associated with climate factors. Also, future weather attributes will be projected. Finally, water main failures will be predicted in the future based on the final models. For the first objective, various climate-related covariates were collected from the literature. These variables are calculated using daily temperature and precipitation. To examine short-term and long-term effects of climate on water main failure, covariates are considered in different periods. Then, to investigate the relationship between different attributes and understand the contribution of each attribute to the target, correlation analysis, decision tree, and chi-squared will be utilized. Second objective is to predict the water main failure. As the target is whether a pipe will break or not, a binary classification problem is going to be solved. The most frequent machine learning algorithms used in recent papers were collected and listed based on their performance. In this project, XGBoost, logistic regression, decision tree, and k-nearest neighbor will be used. Finally, the developed models will be compared using various goodness measures. Then the best performing model will be considered for future steps. For this objective, we use a statistical downscaling model to project future weather attributes based on CMIP6 scenarios, and we use CANSM5 as a GCM. The CMIP6 scenarios used are SSP1 to SSP5, which represents different socioeconomic pathways. We consider 4 weather attributes, including minimum, maximum, and mean temperature, and also precipitation. As shown in the picture, we consider 4 large-scale grid boxes. Objective, we use future weather attributes and factors which gained from third objective, and also our water main failure prediction model to forecast the likelihood of water main breaks in future. Then, for evaluating our final model, there are 2 approaches. First, we are going to compare our results with literature, and then we are trying to find similar pattern between observed and prediction data.
The focus of this project is on Kitchener and Waterloo City. We are going to compare these 2 cities. We have 3 datasets. 2 of them are water main and water main break, which are downloaded from Kitchener City Open Data, and the third one is with weather data, which is downloaded from Environment and Climate Change Canada website. It should be noted that water main and water main break are flattened using GIS. The histogram of pipe age in Kitchener City show that most of them are in their early ages. This figure determines that cast iron pipes are the oldest ones, although this pie chart shows that PVC, ductile iron, and cast iron are the most commonly used material in pipes. This figure shows the average monthly precipitation and show that in July and September we have the most precipitation, and the last figure shows the average monthly temperature.
The break status was examined using statistical methods for our project. As a result, we quantified the strength and direction of the linear relationship between the variables using Pearson correlation coefficient. On a slide, we represented correlation coefficients for each attribute and break status. The decision tree algorithm allowed us to predict break status based on input variables. We used discretizing to represent numeric variables as the decision tree algorithm could use it. Remaining steps are completing pre-processing, finalizing attribute selection, train and test validate modeling, forecast future weather attributes and factors, predict future water main breaks, and evaluate the results.